Hello, this is Chris Horan here from ISG. Today we're going to have a look at DNS on the local intranet. So we're going to have a quick look at DNS. We're going to have a look at zones. Throughout this presentation, if you're new to DNS and you want to replace the word zone with database, then feel free to do that. It might make it a bit easier to learn. We're also going to look at resource records. These are the records which are stored in the zones or stored in the database. And then we're going to have a look at a fault-tolerant implementation of DNS and why it's important to use a fault-tolerant DNS. So, quick introduction overview. DNS maps names to IP addresses. So, it takes a name like www.google.com and then it maps it to an IP address, so 83.64.2.7 or something. DNS does not create connections, so it's nothing to do with the routing of those packets which are used in internet traffic. It's simply the method of converting a name to an IP address. Final bit of revision here for you. The FQDN, which I'll refer to on a number of occasions throughout the presentation, stands for Fully Qualified Domain Name and is a representation of both the computer name and domain name. So in this case here, computer1.contoso.com. So let's have a look at what DNS actually does, just for a very quick overview. So we've got a computer on the left hand side, a DNS server on the right hand side, and then an intranet server on the bottom right there. So in the browser the user types in intranet1.contoso.com. When he presses enter or go on that, and then a DNS query is sent out in the blink of an eye for the IP address for the FQDN intranet1.contoso.com. And providing he's got the DNS server as shown there, put it as his DNS server on his IP configuration, then he'll get the DNS response, which is that. So the IP address for the intranet1.contoso.com equals 10.1.1.12. He can then go ahead and connect to that because he has the IP address of the server and he connects to it using that IP address. So DNS resolution, the textbook representation of DNS resolution is a hierarchical distributed database that contains mappings of domain names to various types of data such as IP addresses. Now the hierarchical distributed database aspect of DNS we're going to look at later. For this particular tutorial we're going to look at the facts that it contains mappings of domain names to various types of data such as IP addresses. That's what we're going to focus on today. DNS uses four methods to resolve queries, namely cache, zone, forwarding and route hints in that order. The first one, the cache, we're going to look at later, but today we're going to have a look at zones. So we're going to have a look at DNS on a zone and how a zone is used to resolve DNS queries. So let's look at our scenario again. User types in intranet1.contoso.com. DNS query is sent to DNS1.contoso.com. Okay. Now, the first place it looks is the cache. The second place, which we're going to look at later, the second place it looks at is the zone. So there's DNS1.contoso.com. It's got the zone contoso.com stored on it, and within that zone there is a resource record, and then in this particular case an A record, which is saved and is used to resolve that FQDN. So the FQDN there is resolved, and that gives the IP address back there. And the IP address is then used to connect to the intranet1.contoso.com. So a couple of terms here for you to get used to. We've got a zone, which again you can replace with the word database just to get your head around this for the time being. The zone in this case is called contoso.com. We've also got something called a resource record. So a resource record is a standard DNS database structure containing information used to process DNS queries. In this case, it converts the FQDN to that IP address there. The in, incidentally, stands for internet, in this particular case on those records. So that's a textual representation of the A record for intranet1.contoso.com. So let's have a look at forward lookup zone. So forward lookup zone simply is the place where A records are stored. There's other records stored within it, but the main reasoning for forward lookup zones is to store these A records, which maps the FQDNs to IP addresses. Some terminology for you now, the word authoritative. Now what authoritative means is if a particular zone is authoritative for a server, then the A record for that server is stored within that zone. So let's have a quick look at that. Here we've got to the server DNS1.contoso.com with a forward lookup zone configured. Within that forward lookup zone, it's got web1.contoso.com in a 192.168.1.1. Now, in this instance here, the query from the local machine will be for that FQDN web1.contoso.com, and that server is authoritative for that A record. So because it's authoritative, it will reply with an authoritative response and give the IP address for that server. The client then connects that server using that IP address. Here we've got litware.com, which is also on the internet somewhere. We've got contoso.com on the internet somewhere else. Litware.com hosts the A records for its zone. So in this case, we've got an example here where it hosts the record web1.litware.com. So let's have a look. The local machine does a DNS query to DNS1.litware.com for the IP address, or for the FQDN web1.contoso.com. Now that is the DNS server which it's querying is not authoritative for that FQDN because the A record is not stored on that zone. So what does it do? It uses something which we're going to look at in detail later called root hints. Basically it goes out on the internet to find that A record for that particular server, and we'll go through that full process in a later slide. Let's have a little bit more look at the detail of the service and the records that are stored in DNS zones. So the one record which we've looked at, so I'll draw your attention to quickly, is the A record. So that's the second one up. The A record again maps the IP addresses to an FQDN, so you'll put in an FQDN and an IP address will be returned. That's an A record. Now, there's three other records to look at briefly here. SOA record, for the time being, all you need to know, that stores configuration and settings for the particular zone. So every zone will always have an SOA record. An SOA stands for Start of Authority. It's the first record that appears in the zone, and it's the record which is used, like I say, for configuration. The NS record, or the name server record, basically specifies the DNS servers which are being used to host a zone in that particular zone. So, for example, if there was 3 DNS servers hosting the zone, then you would have 3 NS records. For a physical DNS to host a zone, it needs to have an NS record. And here we've got an example of one here. So we've got contoso.com zone, and then that maps then through intranet and name server to DNS1.litware.com. The final zone, the final name we're going to look at, is a name which everyone will be familiar to using. Certainly, if you haven't heard the name, then you're all used to using the term www. That is an alias. That's an alias for a particular server in an environment. So if a company decided to create a web server called web1.theircompany.com, then what they would do is then they would put a CNAME record on there, or an alias of www.theircompany.com, and then that would map to their computer1.theircompany.com. So every time you type in the word www, you're in fact using an alias, and we're going to look at that in a little bit more detail now. So let's have a look at CNAME. We've got that there's complicated name. It's one way of remembering the actual name is a canonical name, which is used is what CNAME actually stands for there. So we've got a forward lookup zone. Within that forward lookup zone, we've got an SOA record, which we know stores configuration information about the zone. We've also got one NS record, so we know that there's only one DNS server within the zone. And we've got 2 A records there for 2 separate machines. So we've got web 334131 and web 998877. Now obviously if you're working away in that company, you don't want to be typing in that every time you want to go and have a look at the web server. So what they do is they create a CNAME record. In this particular instance it's called intranet.contoso.com, and then that maps to that more complicated name. So when someone is using their local machine there and types in the word intranet.contoso.com, the DNS resolver will look at the CNAME record there. This point here, it takes you through the first one, which is intranet.contoso.com, through that, and then points that to web 334131. It then looks for the web 4131 and then maps that directly to an IP address, and gets the IP address, and then the computer can connect to that web server, no probs. So this is the same sort of scenario here, but we've got a bit of a change. This server down the bottom here has been taken offline for whatever reason. So someone's gone into the zone, and then they've changed the. They need to now change the CNAME record so that it points at the other web server. So at the moment it's pointing at web 334131. So I'm going to go in and make a change, and then it will now point at web 998877.contoso.com. Same thing happens then with a DNS query. Queries that FQDN goes through the first CNAME record, then goes through the A record and maps that accordingly. So then that responds with the IP address, which the machine can then connect to. So the first thing that's done is someone puts in a second DNS NS record, which shows that there's going to be two DNS servers being used. The second DNS server is now built, and the first thing that needs to happen is that the secondary zone is put in place and given exactly the same name as the primary zone. So you create a secondary zone, you give it exactly the same name as contoso.com. It has to be the same name, or else it won't do a zone transfer. If all the IP and everything's configured correctly, then a zone transfer will occur, and all of the information from the DNS1.contoso.com will transfer over to DNS2.contoso.com. The secondary, this is now a secondary server, as it hosts the secondary zone, and is a read-only version of the primary server, or the primary zone. So you can make no changes to the secondary zone. All you can simply do is read from that, but it still provides that fault tolerance. So let's have a look at a disaster scenario here, where DNS1.contoso.com, which is the primary server, goes down. What you can see when you configure your client machines, you see that you can configure two DNS servers on those client machines within your IP configuration. So you can see there, this particular machine here has got those two DNS addresses configured on the machine there. So the primary one, which is set at DNS1.contoso.com, is tried first. If there's no reply, then it tries the second one, which is DNS2, which in this case is the IP address for DNS2.contoso.com. The queries that put out and then responded in the same way as before. So we'll have a quick look at zone transfers now. We'll have a further look at zone transfers in subsequent slides, but for the time being, all you need to know is the zone transfer is always transferred from the secondary server. Okay, so always transferred from, it's always started by the secondary server. It occurs in those four ways there. It can be manually initiated. When a new secondary server is created, then it automatically does a zone transfer. As we've said before, the SOA record stores a number of configuration settings, and one of those configuration settings is the refresh interval, so how long it'll take before the secondary server will do that refresh. By default, it's 15 minutes, so that's the third time that a refresh will occur, or a zone transfer will occur. Finally, there's something called DNS notify, which basically is the primary server telling the secondary server to initiate a zone transfer. Again, the secondary server is the only server that can initiate a zone transfer, because it actually does an SOA query, a start of authority query, and checks the increment number of the particular zone. But we're going to look at that a little bit in more detail later, so don't worry too much about that for the time being. So you've had a look today at DNS, you've had a look at zones, resource record, and a fault-tolerant implementation of that zone. Next time we're going to have a look a little bit more at DNS and look at using cache, using the root hints, and we're also going to go into the domain namespace, which allows this hierarchical distributed database to work. We're going to look at DNS zone delegation, forwarding, and stub zones. And that about covers everything we're going to look at this time. Thanks for your time.